this video, I'm going to explain Unit 3 periodicity. In this unit, there are 6 subtopics for SL and 5 subtopics for HL. In this video, I'm going to explain the first 3 subtopics for SL. They are periods, groups, and blocks, periodicity and electron configuration, periodicity in properties of elements. So from these 2 subtopics, you need to know how to identify the positions of metals, metalloids, and nonmetals in the periodic table. The 4 blocks associated with the sublevels SP, D, F should be recognized. A copy of the periodic table is available in the data booklet. You will get a clean copy of data booklet when you have the final IB exam. And you also need to know how to deduce the electron configuration of an atom up to Z equals to 36. I will skip this because we already did this in the previous video about electron configuration. And you also need to know about groups that are numbered from 1 to 18 and with their classifications: alkali metals, halogens, transition elements, and noble gases. Okay, this is the periodic table, and this one the real periodic table that you will get it or you will find it in the chemistry data booklet, right? So the periodic table with their key label groups: alkali metals, transition elements, halogens, noble gases, lanthanide, and actinide series. Okay, so group 1 elements are in the alkali metals group, and transition elements are the metals in the middle section of the periodic table, this one. And group 17's nonmetals are for halogens, and group 18's noble gases. Lanthanide and actinide series are placed separately at the bottom. We don't really talk about lanthanide and actinide series in the IB chemistry, but however, this series contains rare earth metals and they have radioactive properties. And the periodic table also, it contains 3 different characteristics: metal, metalloid, and non-metal. So metal is on the left side, this one and this one, group 1 and group 2, and also transition elements. Metalloid, zigzag location, okay, between metal and non-metal is on the right side, okay. And also we can categorize the blocks that are in the periodic table. On the periodic table, they are S, P, D, F. So S are the elements from group 1 and 2 because their valence electrons fill the S orbitals, and the transition elements, they fill the D orbitals, and nonmetals, they occupy the P orbitals, and actinide and lanthanide series, they fill the F orbitals. In the periodic table also, how the elements are grouped, okay, in the same group. For example, H, Li, and A, why they are categorized in the group 1? Because they have 1 valence electron. So valence electrons are the electrons on the last shell or outermost shell. So group 1, it has 1 valence shell, so it represented by the red dot. So all the elements in the group 1, it has 1 valence electron. Group 2, 2 valence electron. Group 13, 3 valence electrons. Group 16, 6 valence electrons, like in oxygen and sulfur, it has 6 valence electrons. And group 18, except helium, it has 8 valence electron, okay. And the number of shells, categorize them in the same period. For example, for period 1, it has 1 shell. For group period 2, it has 2 shells. For period 3, it has 3 shells, and so on. Okay, so do you notice any patterns in the number of valence electrons? Yes. So across period, the number of valence electrons increases up to 8, which is group 18. Okay, Which of the following elements is a metalloid? Okay, Ca comes from metal, and then Mn comes from transition elements, and then C comes from metal, and then germanium comes from metalloid. So the germanium is here. This is metalloid. So for Mg and for Ca is metal, for Mn is a transition element, and C is a non-metal. So use the IB periodic table to identify the position of the following elements. So we've got helium, chlorine, and barium. So for period and group, okay, so these are the period, okay, from the left to right period, from up to down, it's group. So helium is group 18, period 1. And the other element, chlorine and barium. So chlorine, Cl here, so it's group 17, period 3. And then barium, Ba, so group 2, period 6. So let's write it here. So helium, period 1, group 18, chlorine, period 3, group 17, period 3, group 17, barium, period 6, and group 2. So period 6 and group 2. Okay, so the next subtopics, you need to know how to explain the periodicity of atomic radius, ionic radius, ionization energy, electron affinity, and electronegativity. So there are 5 trends on the periodic table. They are atomic and ionic radius. There are also ionization energy, electronegativity, and electron affinity. Let's start with the atomic radius, okay? So the radius from the middle up to the last shell. So when we compare between Li and K, Li has 2 shells, right? This one. And K has 1, 2, 3, 4 shells. How do they have different number of shells? Because they have different number of electron. So Li comes from period 2, so it has 2 shells, and K comes from period 4, so it has 4 shells, and Cs comes from period 6, so it has 6 shells. So the bigger number of electrons, the more number of shells. So if it has more number of shells, like for example, K has 4 shells and Li only has 2 shells, so K has bigger atomic radius than Li because K has more number of electrons, therefore needs more shells to accommodate this all electrons. So when you go down a group from H that has 1 shells only, Li that has 2 shells, and A 3 shells, so until here even 6 shells. So when you go down a group, the number of shells increases, therefore the atomic radius also will increase. So that is from up to down a group. And what about period? Okay, so here is Na and this one is Cl. Okay, Na and Cl comes from the same period, which is period 3. So they will have the same number of shells, right? So Cl number of shell is 3, also Na3. Okay, look at here. But why Cl atomic radius is smaller? Look at to the proton number. Cl has a proton number of 17 and Na is only 11. So the charge is also different, right? So now what makes them different? It's because of the charge and nuclear charge, and also the protons number. The bigger charge and the bigger protons number, the greater attraction from the nucleus to between the nucleus and then the electrons. Therefore, it will squeeze the size of the atom. So when you go across a period, the size of atom decreases, okay, because of greater attraction due to having higher number of electron and charge. So this is the trend. The red dot represents alkali metal. So when you go down a group, the atomic radius increases, and the green color is halogen, blue color is noble gases. So when you go across period, atomic radius decreases. Now let's compare the ionic radius with its parent atom. Li comes from group 1, Li, Na, and K. Okay, so group 1 has one valence electron, so it loses one electron, so the charge is +1. Right, Li comes from period 2. Okay, Li comes from period 2, Na period 3, K period 4. So Li, it's not ion, has 2 shells. Okay, and then Na 3, K it's 4. So when one electron is removed, this becomes one shell, and then this one becomes 2, and this one becomes 3. So the size decreases. Therefore, for Li+, the size is smaller than the Li. So ion, especially cation, positive ion, has smaller size compared to their parent atoms. The same with Be2+. Be comes from group 2, lose 2 electron. Be comes from period 2. Okay, so it has 2 shells. So Be, it has 2 shells, and then Be2+, it has only 1 shell because lose 2 electron. The same thing with Al. Al, it has 3 shell, comes from period 3. Okay, so this one 3 shells becomes 2 shells, so decreases. So the conclusion is, when you compare the parent atom and cation, I mean positive ion, the positive ion size is smaller than their parent atom, but the opposite with the anion or negative ion. So F- gain electron, therefore the size of anion is bigger than their parent atom. Okay, now let's compare between ions Na, Mg, Na+, Mg2+, Al3+, and Si4+. So Na+, with number of electron 11, lose 1 electron, becomes 10 electrons now. Mg with 12 electrons becomes 10 electron as well. Al, 13 electron, becomes 10 electron because loses 3 electron. Si, 14 electron, now becomes 10 electron as well. So they have the same number of electrons, but why don't they have the same size as an ion? Right, so remember when I said about the atomic radius? When you go across a period, the charge increases and the number of protons increases as well. This causes greater attraction between the nucleus and the electrons. So the attraction in Si4+ is the greatest compared to other 3 ions. So that's why Si4+ has the smallest ionic radius compared to Al3+, Mg2+, and Na+. And what about here? Okay, for non-metal, note that Si can lose or can add 4 electrons. Okay, they are in the middle. It is in the middle, Si, on the periodic table. So Cl- has a greater protons number. So the attraction forces is the greatest. Okay, and also because of the charge, again, it across a period. So the atomic radius decreases, the same with ionic radius as well. Okay, next, let's continue about ionization energy. Is the energy required to remove an electron from gaseous atom. Between the ionization energy and atomic radius, there is a correlation. Okay, ionization energy is the energy required to remove an electron. So now, when we have bigger size of atomic radius, therefore the attraction between the nucleus and the electrons is getting weaker. I mean, weaker compared to the the atom that has smaller radius. So it will be easier to remove the electron, therefore requires less energy. So for example, the one that has 3 shells, okay, the atomic radius is bigger compared to 2 shells. So the attraction here is less compared to this one. Okay, so this is the attraction. So because it has this bigger attraction or stronger attraction, therefore to remove the electron here, it's quite difficult compared to this one, right? So that's why when you go down a group, the atomic radius increases, the attraction force decreases, so the amount of energy required to remove the electron also decreases. But when you go across period, the atomic radius decreases because of the attraction forces increases, therefore it will be harder to remove the electron, so the ionization energy increases. Okay, so when the question asking you why increases the ionization of this increases, why decreases, so you can use the reasons based on the atomic radius and then relate it with the number of shells and electrons, things like that. Okay, next about electron affinity. Electron affinity is the amount of energy released when this electron is attracted to this gaseous atom. Okay, so it becomes an ion and it has a unit, okay, kilojoule per mole. So this is for electron affinity, the amount of energy that is released. So what's the difference, what's the trends when you go down a group and across period? Down a group, the atomic radius again increases, okay? So this electron will be easier to be attracted. So the amount of energy that will be released smaller. So when you go down a group, electron affinity decreases. And when you go across period, the atomic radius decreases, right? Because the attraction is stronger, getting strong, right? So to get attracted, it will be difficult because it's like, it's so dense. I mean, like they are stable. I mean, because of the attraction is strong. So to disturb and to get attracted, so it releases more energy. So across period, electron affinity increases. Down a group, decreases. And somehow when you need to do calculation, electron affinity, its number is provided in the data booklet. Okay, this one. So on the right side here, okay, this is the electron affinity and ionization energy, but first ionization energy on the left side here. Okay, so next, let's talk about electronegativity. What's the difference between electronegativity and electron affinity? Electronegativity is the tendency of an element to attract a pair of electron of a bond towards themselves. This is a bond, right? HF. So which one is more electronegative? It will have greatest attraction. H, it's more positive, and F is more electronegative. So F, it will cause a greater attraction of the electron pair of a bond will be attracted, or the tendency of this element to attract a pair of electron is greater compared to H. Right, so what about the trends? Okay, so the key here that is important when you move towards, I will just use this basic one. Okay, when you go towards F here, okay, and then when you move away from F, okay, this is the key. So when you go towards F, the electronegativity increases because F is the most electronegative element on the periodic table. And when you move away from F, the electronegativity decreases. You can see the number here, electronegativity, at the bottom here. Okay, this one. F this is the highest, 4. Right. So why F is more electronegative than Cl, more than Br, more than I? Okay, the key here, when F wants to attract the pair of electron, the attraction will be stronger when the atomic radius is smaller. So for example, F, the radius only here, smaller than Cl that has 3 shells. So the attraction forces is greater in F because the distance, the radius is smaller, right? So to reach this electron pair, F to the electron pair, Cl to the electron pair, F, it has smaller distance, therefore greater attraction. So that's why F is the most electronegative element. And even when we compare between F and O or F and N, F has smaller atomic radius. Okay? Which properties of the period 3 elements increase from sodium to argon? Sodium to argon. So across period. When you go across period, the nuclear charge increases, +1, +2, but atomic radius decreases, right? Because it has bigger proton number and charge. So the one that has atomic radius, of course, strong. Okay, what about electronegativity? It goes from Na to Cl, so from left to right. The same like this, okay? So when you move from left to right, the electronegativity increases because you go towards the direction to F. So the answer is C. Which of the following are properties of gaseous atom? Ionization energy is the energy required to remove an electron from gaseous atom. Electronegativity, the amount of energy that is released when an electron is attracted to the gaseous atom. Electronegativity is the tendency of an element to attract a pair of electrons of a bond toward itself. So it doesn't need to be gaseous atom. So the answer is 1 and 2. Identify the element which is likely to have an electronegativity value most similar to that sodium. The key here, elements should be diagonally next to each other. So let's see with sodium. So sodium and then Ca, this one, diagonally. So the answer is Ca, B, right? So we just talk about the periodicity or periodic table, right? The groups in the periodic table and the characteristic metal, non-metal, metalloid, groups, alkali metal, halogen, noble gases, actinide, lanthanide, and also the blocks SPDF, also the trends of the valence electrons and the periodicity trends. There are ionization energy, atomic radius, ionate radius, electronegativity, and electron affinity. So in the next video, I'm going to explain about the reactions of group 1 metals with water and group 17 elements with halide ions. Also the equations for the reactions with water of the oxide group 1 and group 2 metals, carbon and sulfur, also the acid rain and ocean acidification, right? Believe in yourself and believe in me. With the Nail IB, the best online platform, can help you to get that perfect score of 7 in your final exam. See you in the next video.